So let's take a look at that formula to determine what should I choose, bank A or bank B, depending on what it was. Let me rewrite that problem that we discussed on the previous page so we can actually finish it off and determine which one of those two banks should have I picked. I'm going to rewrite what we wrote on the last page. So to remind ourselves, Bank A was 7% compounded daily, and Bank B was 7.1% compounded semi-annually. Again, if I'm making an investment, I traditionally want the higher interest rate, which would be Bank B, but I also want the higher compounding rate, which would be Bank A, so I'm in a question of which one do I choose. So the formula that I'm going to use, which actually isn't provided in our textbook, but I've written it for you here, it's the annual percentage yield, or the effective rate formula. This is going to give us our answer as a decimal, and then we need to convert that decimal to a percentage as a percentage rate. So you want to compare, if it's an investment, which one of these two has a better effective rate, a better interest rate. As long as it's an investment, I want the higher one. Again, if it's a loan, I would want the lower one. So how are we going to do this? Well, let's consider the annual percentage yield for each one of these two different formulas. The annual percentage yield is given by 1 plus r over n, so this would be 1 plus r, which would be 0.07, divided by n, which would be 360 using Banker's rule, to the n, which is 360, minus 1. Let's go ahead and try that now. My annual percentage yield would be, plug that into your calculator and see what you get. I do want you to be careful and realize that that minus 1 is not in the exponent, that you do need to put it hit the right arrow on your calculator to get out of the exponent to do the minus 1. I'm ending up with 0.072500, which is approximately 7.25%. So, Bank A at 7% compounded daily is essentially the exact same as 7.25% annual interest rate. What about Bank B? Let's see what Bank B is. Let's go ahead and plug those numbers into the formula as well. I would have, to calculate the annual percentage yield, I'd have 1 plus r, which is 0.071, divided by n, semi-annually is twice a year, raised to the second power. Again, this is not in the exponent. We have that minus 1. Go ahead and plug that into your calculator, and let's see what you get. I'm getting 0.07226. That's enough decimal points. So if I want to convert that to a percentage, moving the decimal to the right, that would be about 7.23% approximately. So which one of those two is better? Well, if it's an investment, it seems that Bank A is giving me the better effective rate, or the better overall interest rate. If it was a loan, I would want to choose Bank B because it's giving me the lower of the two. So again, anytime it's an investment, you want the higher of the two interest rates, effective rates. Anytime it's a loan, you want the lower of the two effective rates. So again, it allows us to compare two interest rates that have two different compounding periods. We want to use the effective rate formula. So let's go ahead and look at their example now. Oh, by the way, there's how you put it into your calculator, even though you've already done that twice. It's perfectly fine. I do want to emphasize once again that you do need to hit that right arrow to get out of the exponent on the TI-30XS to make sure that minus 1 is not in the exponent. So example 11 says a credit union offers a certificate of deposit at an annual interest rate of 3% compounded monthly. Find the effective rate. Round to the nearest hundredth of a percent. So our final answer needs 2 decimal points. So we're going to use the APY formula. The annual percentage yield is 1 plus r over n raised to the n minus 1. Let's go through and identify our variables. 3%, that gives me r is 0.03. Compounded monthly, that says n equals 12. Those are the only two variables we need for an effective rate. So here we're going to have 1 plus 0.03 divided by 12 raised to the 12 minus 1, which is not in the exponent. Go ahead and plug that into your calculator. Let's see what you get. I'm getting 0.0304, which is approximately 3.04%. Remember, if I need my hundredth of a percent, I actually need to round to the nearest 4 decimals. 3.04% would be my final answer. Let's look at example 12. One bank advertises an interest rate of 5%, 5.5% compounded quarterly on a certificate of deposit. Another bank advertises an interest rate of 5.25% compounded monthly. Which investment has the higher annual yield? So again, if I was looking at just the rate, I would want 5.5% because it's higher. If I was looking at just the compounding period, I'd want monthly because it's higher. So which one of these two banks is the best one? Well, let's go ahead and break it down by cases. There's the case of the bank with the 5.5% and the case with the bank with the 5.25%. We're going to calculate the annual percentage yield for both of these, so I'm going to write down the formula. That's 1 plus r over n raised to the n minus 1. And I'll plug in the number for both of these. For the 5.5%, it would be 1 plus 0.055 divided by, that was compounded quarterly, so that's a 4, raised to the 4 minus 1. Go ahead and plug that into your calculator. I'm getting 0.056 if I go to about 3 decimal points. Let's put in the 5.25%, so my annual percentage yield here would be 1 plus, will be 0.0525, all over, well, this was compounded monthly, so that's a 12 now, raised to the 12 minus 1. Plugging that into my calculator, I'm getting 0.054. So if I wrote these as percentages, this would be about 5.6% would be my effective rate. And as I wrote this one as a percentage, that'd be about 5.4% is my effective rate. So again, this is a bank. You're going to be investing in this bank. You're going to want the higher of the two. So which one has the higher effective rate? 5.5% compounded quarterly is the higher effective rate, or the one that you want to invest in. So what I like to do in these sections is just kind of summarize the sections by saying, here are the formulas that you need to know or that you will be using. In this section, we use 3 formulas. A equals P times 1 plus R over N to the NT, the compound interest formula. Solve for A. We used P equals A over 1 plus R over N to the NT. That's the compound interest formula. Solve for P. And the last formula that we used was the annual percentage yield formula, which is the annual percentage yield or effective rate is equal to 1 plus R over N raised to the N minus 1. I'd have all 3 of those written down on a note card if you get to use the note card during the exam. If you don't get to use a note card, those formulas will likely be provided for you.